Hey, good morning, everybody. Good morning to our new IDS webinar on the IDS Reference Architecture 2.0. My name is Sebastian Steinlos. I'm the lead architect of the IDSA, and today I'm glad that Professor Boris Otto, the head of the Fraunhofer Institute for Software and Systems Engineering and co-chair of the IDSA Executive Board, will talk about data governance. This is the third part of our webinar season. We already heard Lars Nagel, Managing Director of the IDSA, in the context of the IDS, and Dr. Christoph Quick from the Fraunhofer Institute for Applied Information Technology on the process layer of the IDS. If you're joining our webinar live today, you can ask your questions afterwards in the questions and answers block. You can ask directly or write the questions down in the chat. I'll read them out loud afterwards. If you join our webinar later on YouTube, just comment below and come back to us via email or give us a call. If you like the webinar, just hit the button below. Boris, I'm happy to have you here today for your talk on data governance in the context of the IDS. As I know, this is one of your research topics, and I'm really looking forward to your talk. So please go ahead.
Sebastian, thank you very much for the introduction. Yes, also warm welcome this morning from my side, Boris Otto. And I'm really glad to have the opportunity to share a couple of thoughts within this webinar with you, because, well, data governance is one of my favorite topics, so to say. I'm researching in data management with a particular focus on data governance for, well, more than 1.5 decades already. And that basically also introduces a little bit how I structured the presentation. So I would like to walk you through, let's say, 3 fundamental pieces of data governance. First, I'd like to start with a brief history of, let's say, where data governance comes from and what original drivers for this concept were. In the second point, I'd like to transfer what we learned over the last, let's say, 10, 20 years in data management, mainly to, let's say, new requirements that business ecosystems pose on the way we manage data in general, but also, let's say, on how we govern data. And then, of course, in the next and the third part of the presentation, I'd like to touch upon the point, well, what would be the IDS approach on data governance, in particular in business ecosystems. So if we jump right in, we must observe that, let's say, the roots of data governance clearly lie in the late 80s, in the 1990s of the last century. And the origin or the driver to deal with data governance in the first place was mainly compliance. I have brought with me here three examples that basically set the scene, so to say, for data governance, as I said, in the 1990s of the last century. And one needs to understand that by that time, data management was mainly understood as database management, right? So everybody was really concerned with database management systems, and also the uprise of, let's say, ERP systems basically stressed the point that we would have, let's say, one integrated source of data. But if you would ask, let's say, a company, well, how did you deal with data management in that time, in the 1990s, probably everybody would say, well, it was mainly an information technology function, which was mainly in the ownership of the application owner of that database system. So, but then a couple of incidents occurred, and some of you might remember the big case of Enron and Arthur Andersen. Enron was by that time one of the leading energy companies in the world, US-based, and it basically went bankrupt through, well, fictional financial reporting, which was also backed up by the entire executive management and was not, let's say, revealed by the advisory board nor by Arthur Andersen as the auditing firm. So that basically led to the fact that both Enron as a large corporate group really went off the market, and also Andersen as the auditing firm followed immediately after that. So in the case of Arthur Andersen, 85,000 employees lost their jobs in consequence of that incident, and as I said, Enron was basically was taken off the corporate landscape in the US. And mainly it was due to the fact that nobody really had an idea about, let's say, what the quality of the financial data was that was reported. And it was also not possible to retrieve responsibilities for the mistakes that happened. So literally nobody could have made responsible. which in the end led to the fact that basically the entire company went out of business. A similar case, different domain, of course, different continent from Europe. It was Sandoz, one of the leading chemical companies by that time. By the way, now major parts of Sandoz are now Clarion still in Switzerland. And as it happened by that time, a couple of times, chemical substances were spilled into the River Rhine. That was in the late 1980s. And of course, acknowledging the fact that it is a bad incident per se, it even worse because nobody was really able to clearly create transparency about the nature and also the implications of that chemical substances that was spilled. And that was also due to the fact that really data quality and the quality of in that particular case, the master data of that chemical materials, along with, let's say, the environmental and health data related to this material master data, was literally not existing or was not available in cases like this accident. And the other thing, which was of course not so much of a catastrophe, but was a clear driver for also data governance, is a little bit younger in years, mainly from the early years of this century, taken from DB Netze, which is basically the infrastructure service provider of Deutsche Bahn Group. So basically, they make sure that all the railway tracks are in good shape and can be used by railway operators. And as you know, this division of the company is still, as the entire group, state-owned. But the owners, so the state of Germany, wanted to create more incentives for, let's say, better and more efficient maintenance and servicing of the infrastructure, and connected, so to say, the financial contribution that was granted every year to Deutsche Bahn to the quality of the infrastructural data that was reported in a so-called Infrastrukturkataster, so an infrastructure inventory. So that was a nice case because, driven by a regulation, there was a direct link between the quality of data on the one hand side and the financial situation of the entire company of the other. So these three examples set the scene, so to say, how data governance was initially seen, driven by regulations, by compliance, and it forced companies to deal with data not only from a database management perspective, but rather from an organizational perspective. And it also posed questions like, who is in the end in our company responsible for the data itself, but also in particular the quality of the data. And that tells you also a little bit what data governance is about. It's about setting and assigning, distributing accountabilities for the use and management of data. That is basically what data governance is about. So why is that important? It was gaining more and more attention, let's say, over the last 15 years, I'd say, because many companies were confronted with a couple of different business drivers next to compliance, which we just talked about. For example, smooth business integration, so mergers and acquisitions was a big thing and still is. A 360-degree view of the customer, so multiple divisions in the same corporate structure operate with the same customer, and if, let's say, all the divisions refer to the customer with different customer master data codes and also basically name the customer differently, then you won't be able to, let's say, generate a comprehensive and integrated value proposition to the customer. Of course, integrated and automated business processes across different functional silos was another driver, and simply the single source of the truth for business reporting, and that were basically driven by very, very simple questions like how many customers do we have across all divisions, how much revenue did we make in the last financial year, and many companies felt that they had severe difficulties in reporting these numbers to very, very simple and basic questions, and said, well, okay, we need to address this issue and we need to manage accountabilities and responsibilities for particular data domains on a company-wide basis. And that is basically also depicted in this chart here. Many drivers for data and for data quality affect the company as a whole, and therefore you also need to set up, let's say, a company-wide regime for managing this data. This issue cannot be solved in one division, in one unit, in one location alone. Talking about the quality of data, the typical situation that we still find in many companies is depicted here. So assuming you would measure, let's say, the data quality over time, and of course there are different dimensions which basically represent data quality, for example, consistency, up-to-dateness, completeness of certain data sets. So it's a multi-dimensional construct, and that we can measure in a database, for example, or in data flows between different systems. And imagine we would do that and track this data quality metric over time. Then usually what happens is that the quality level goes down. And that is a law of nature to a certain extent, because data quality or data itself is just a representation of reality, right? And if reality moves on, what happens all the time as we talk, and we do not update the data accordingly, the quality of the data goes down. And the interesting thing in many cases was, as in the examples that I mentioned, that since quality goes down, nobody in the company was really interested, right? Because it's not a very attractive topic. People do want to deal with more, let's say, attractive, more sexy topics in the company, like, for example, digital business models or new revenue potential in China. And so data governance and data quality were always considered, let's say, not so cool topics in companies. And that is what you can see here. Usually what happens is nothing until, let's say, these issues arise. So nobody's really able to tell what chemical substances were spilled. Nobody is really able to respond to questions like how many customers do we really have? And then it gets hectic, right? People start task forces and consultancies are hired and data washing machines are bought in order to bring up the level of data quality to a sufficient level. And that usually happens, and people succeed in that endeavor. And then we have, let's say, this peak after project one, which is usually a Friday afternoon, where everybody comes together and is really happy that this project was completed and the mission was accomplished in this limited amount of time. And then the same thing happens over and over again. And this is because many companies still understand data governance and data quality as a project, but of course it's not. What is needed is, let's say, the establishment of a continuous initiative and effort to keep the data quality above a certain threshold within the company at all times. So you need to build a capability that does that in a continuous fashion. That is also depicted here, because the root causes of, let's say, poor data quality is not so much, let's say, an IT issue, as in the example of Bayer, but it's it is a problem that has multiple roots and causes. Much can be seen on the employee level, because they are not aware of what, let's say, what their activity when they enter certain data items into a system, how that relates to, let's say, a downstream usage of that data. Sometimes people aren't aware that it's a problem if duplicates are entered into a system, right? Data maintenance is usually not controlled. There are no workflows. Usually you have no standard. And on the lower right-hand side, the important thing, no data governance. And if you ask, let's say, nobody is really feeling responsible for data standards, for defining data maintenance processes, and also for setting quality thresholds for certain data classes. So corporate life is pretty hard without data governance, as shown in this little picture here. So you have many people that point into various directions, and the guy in the middle, which is usually either the CFO or the CEO, stands there and is really lost, so to say, without any chance to to move things into the right direction. And data governance basically is an approach to give direction to how a company uses its data resource. So to give you a little bit of, let's say, a conceptual framework, one could, of course, argue that data governance is about, let's say, it's relating to the data resource in a company, and that data resource is managed by the data resource management capability. And so everything what we do in data management has to follow the regime that is laid out in data governance, so to say. And in the end, data governance aims at maximizing data value, whereas on the right-hand side, data quality management as a sub-function of data resource management is aiming at maximizing data quality. And of course, there is a relationship between data quality and data value, which is, by the way, also a nice research topic, because it's not so easy to quantify this relationship. We know that it is there, so the better the quality of the data, the higher its value. But of course, it's also no linear function. So how much do you invest in data quality in order to reach which kind of value? And it depends, of course, on the use context. So data quality is usually considered a fitness of the data for use. And depending on the use case, of course, we need different data quality levels. So as I said, still, despite the fact that we use information systems for business process support for more than 40 years or 50 years even, still there is lots of white spots available in the question, well, how does good data quality relate to business value of IT in the end? Right, so now we see that data has become a strategic resource, and also to give you a little bit, let's say, a research update, what that really means. It's not just a buzzword, well, our data is considered strategic and it's a strategic resource. A resource is mainly what the company owns, controls for succeeding in business. And there are different kinds of resources, and of course, those are considered strategic in the context that they basically are a source of competitive advantage, which qualify to these VRINS framework here on the right-hand side. So they need to have some value. They must be rare in order to differentiate from the competition. They need to be with some imitability in the sense that it's not so easy to copy them. And it's also characteristics or requirements for resources to be strategic, that they cannot be substituted by some other resource. So, and what we see is that, let's say, data is more and more reaching the requirements of this framework, and can really be considered as a strategic resource, because it's really the source of competitive advantage. In particular, if we think of, let's say, smart service wells, new scenarios in business ecosystems, and so on. And of course, it is also important not only to control or have this resource, but also to be able to utilize it. And that brings us to, let's say, the notion of capabilities. And yeah, a capability is also required to deal with the strategic data resource, and data governance is, of course, one central piece in that. We can also look at, let's say, how data behaves in terms of its value. And of course, it behaves differently than tangible economic goods. For example, in contrast to tangible goods, the value of the data does not shrink or diminish with the number of users of that asset, right? Because you can easily copy it without losing any value. Also, let's say we do not have, let's say, depreciation. So there is no, it's not wearing off, so to say, as physical assets, if we want to call it like that. So there is also constant value depending or independent of the usage. And there are a couple of other criteria that have already been studied in the late 90s, which address the issue, well, how does data behave differently in terms of an economic good compared to physical goods? I believe that with that in mind, one would be able also to come up with standardized procedures for accounting for data or for economically evaluating data assets. And that is possible, as the next view graph shows. So we did that, let's say, some 10 years ago in a couple of case studies. And I'd like to draw your attention to the second last column on the right-hand side, which basically is the valuation approach. And what you can do, or what you have available when you ask yourself the question, well, how much are my data worth? You basically have three paths to pursue. The easiest one, so to say, or the more basic one, is the one that Festo also pursued, which is identifying the production cost. So in German, it would be like Herstellkosten also. So what is the cost that occur in order to get possession of the data, either by producing or buying it, and also keeping it in good shape, so maintaining it. And Festo calculated that for their master data for their parts, so basic components and also raw materials, their costs occur in the amount of, let's say, 500 to 5,000 euros per year for every single record. And that is because multiple roles are engaged in managing the data, like the engineering department, the safety department, the logistics department, the sales guys, the product management, and so on. And everybody is involved in making sure that the quality of that part data is in good shape. And that is not for free. That just generates costs, right? So the other thing is, and that is the last line here in this table with Syngenta, you can also calculate the use value of data. So what is the effect of good quality data to the performance of my business processes? And you can also calculate that. And in the context of Syngenta, it's an agrochemical company. They calculated for their material master records a value of 148 Swiss francs a year. And then you can also take a third path, which is basically trying to find a market for your data. So trying to sell it, which will be of increasing importance if we talk about the data ecosystem, the data economy and business ecosystem. And you can generate, of course, a market value if you just sell your information. And by that time, we looked, let's say, in the more consumer-related domains like Facebook and also in the retail business. And of course, you can identify a certain value per data record. Nowadays, we have more sophisticated approaches available because, let's say, in the Internet of Things and in, for example, mobility scenarios, companies like BOSCH think of, let's say, making their data from, let's say, engine control systems in cars available to third parties and also monetizing the data, meaning that they would get, let's say, back a revenue on the use of the data by third parties. So if we, let's say, consider and understand data governance as some sort of, let's say, organizing something, as I mentioned, it is about, let's say, assigning responsibilities and accountabilities on data within the organization. We, of course, have different options, right? And I don't want to go into the details, which is, this is also the central piece of a research paper that I once wrote about, let's say, the different options that you have to distribute decision rights on data across your organization. And a couple of things, it's about, let's say, if we look at the right-hand side, so where to position it, this is the often posed question, well, do I have a group of brains that reports directly to the CEO, or do I have it on a fully decentralized fashion, or is it a virtual organization, or even a shared service center that makes sure that data governance is in place? All these different options can be found in practice, but the choice of the selection of the right model depends a little bit on, let's say, the nature of the company itself. To give you an example, this is taken from BOSCH. BOSCH created data governance mainly for master data in 2008, so some 10 years ago, but it's still valid and in place. And what they did was they introduced into the organization two new roles, which are the data owner here on the left-hand side, and also the data officer. So the data owner usually oversees a certain data class, for example, supplier master data. So the entire stack of attributes that are needed to describe in an unambiguous fashion a certain supplier, both from a purchasing but also from a financial perspective. And that also tells you that this job, the data owner role, really has to go beyond the boundaries of typical functional typical functions in corporate environments. Also, there was, due to the fact that it goes beyond the traditional reporting lines in a company, you need to come up with a virtual organization in terms of committees and bodies where people sit together because of course they have, let's say, different interests and different priorities with regard to the management of the data depending where they come from. To give you an example that was taken from ZF, I was participating in a workshop of such steering committee, which eventually led to a point where the head of accounting, of accounts payable, basically stood up and said, well, you can standardize your suppliers as much as you want, but please let alone my vendors. And that is, so to say, that was really a funny thing because, of course, in the real world, it's the same thing. And that was not really the idea of managing the same data sets end to end. Right, but if you are able to establish data governance, you can also measure severe impacts and contributions to the quality of the data. This is a chart from Bayer, which were able to ramp up, let's say, the quality of the data in the different regions in the world where Bayer is operating. For example, Latin America was not doing so well for a certain period of time, but really through, let's say, accountability, through a strict regime on data maintenance and creation, people were able to level that up to, let's say, over the threshold of about 98% or so. A nice idea I studied when I visited Johnson & Johnson in the US, which combined, let's say, quality management for data with quality management for everything else in the company, basically following a Six Sigma approach. And they were also able to achieve Six Sigma level for the quality of their data. And that would not have been possible without clear responsibilities, clear data standards, a clear regime on which data to use for what purposes, in which manner, and that is exactly what data governance is about. So to sum this brief history up a little bit, there are a couple of best practices that can be identified, and I also basically wrote them down in a book, which I wrote together with my habilitation supervisor, Hubert Österle, where a lot of these cases and best practices are summarized, and they can be, you can download it for free and go into details of what I've just said if you are interested in that. So life's obviously good if you have data governance. So all the sheep are looking in the right direction. You have, let's say, some data stewards, in this case called livestock directional consultant in place, and shareholders and CEO are happy, of course. Also, there are a couple of, let's say, reference models that can be used. One comes from the Competence Center Corporate Data Quality that I founded in St. Gallen back 12 years ago or so, which basically tells you what to do if you want to establish data governance, what has to be in place to be precise, and how you do that is something that we developed at ISST, a methodology that we call smart data engineering that basically takes you from where I am today to where I want to be in terms of, let's say, consistent and managed approach for data governance. Right, so that was basically the history of data governance, and also to a certain extent the state of the art of governing data from a company internal perspective. And that, of course, brings us to the question, well, how can we translate or further develop data governance if we talk about ecosystems, which is, of course, let's say, the upcoming issue and the upcoming topic. So, as said earlier on, the role of data has changed. That is crystal clear. And we have now reached a situation where the data economy is there. So data is not any longer just a pure byproduct of our business processes, as you can see here on the left-hand side, as it was in mainframe computing. And it's not only a process enabler, it still is, of course, we still have enough trouble with making sure that internal end-to-end business processes are in place and are really automated. So this is an issue that prevails, which also tells us that, let's say, governance and data resource management per se is not a project, but it's really something that you have to establish in a company in a continuous and ongoing fashion. And also over the last decade, we have seen data becoming more and more an enabler of products. So if we look, let's say, all the smart products that are out there, for example, one of my favorite examples is a smart ball that is offered by Adidas, which basically is a good soccer ball, a good football, but it's equipped with a sensor that basically generates lots of data about how the ball was kicked and where it goes and so on. And that can be used in order to train more efficiently, for example. And this is a good example how, let's say, data that is generated through a product is an enabler of, let's say, an extended and enhanced product service system, if we want to call it like that. So on the other hand, on the right-hand side, but we also see that over the last years, almost also even a decade, data is the product itself. Data is sold. Even raw data is sold. Also, to give you the example of, let's say, Swisscom, so the mobile communications operator in Switzerland. Of course, as we all know, they track, of course, in an anonymous fashion, the location and position information of their users. And the entirety of this data can, of course, be used to direct public transport system or design public transport systems in a more efficient way. Also can be used in order to learn where you set up construction sites on the motorways and so on. And Swisscom basically sells the raw data for the various stakeholders in Switzerland simply as it is. They anonymize it, of course, but it's not pre-structured, not pre-analyzed. They just sell it as it is. So, and therefore data is a product, right? So, and that brings me to the point that was already, let's say, a little bit introduced by the picture on the title chart of this presentation. You might have noticed that that was taken from an American football game from mainly the New England Patriots. And that refers back to a very, very popular article on the way we deal with data, which was published by Leandro Dalle Mulli on the one hand side, and famous Thomas Davenport on the other hand. And Tom Davenport was one of the key research when it came to enterprise systems, ERP, and so on in the early 90s. And they came up with a nice metaphor of what has changed in the way we manage data. So my brief history tells you that, let's say, data management was mainly a defense game, right? So the key objectives were mainly bottom line driven. So data security, privacy, compliance, making sure that we know what's going on, but mainly directed to the 3 C's. So complexity, compliance, cost. Those were the key drivers for the defense game in managing data. So in terms of core activities, of course, it tells you, well, okay, we need to optimize data extraction. We made a lot of effort in terms of data standardization, dealt with data storage, and making sure that access to data is only granted to people that have the right to use the data. And the clear data management orientation was mainly control. Also, we try to establish single sources of truth, mainly for master data. So only one system where all the customer data resides, right? So what we observe or have been observing over the last couple of years is that the game changes, right? So digital and digitalization in general is a game changer also to the way we manage data, so that it develops from a pure defense game to an offense game, and key objectives are now top line oriented. So we want to strengthen the competitive position of data management, of course, and our core activities are more about how can we use the data, how can we utilize its value for new business scenarios. Data management has to be more flexible in the future, and according to the authors here, we will end up with multiple versions of the truth. That is something that I really doubt, to be honest. I think that we will still have a single source of truth, but that does not necessarily mean that we use the data only in that particular database for the single source of truth. Of course, the data needs to be spread through other divisions, in particular also in ecosystems, but still we need to be able to identify the source of the truth of that data record. So I disagree a little bit with the last item here, but in general, I think it's a good metaphor and a good idea to talk about the game-changing role of data that we observe. Right, and that is nothing that is just a vision or so. The data economy is just there. Deutsche Telekom last week launched their Data Intelligence Hub, which is based on the IDS architecture, and this is a marketplace, a data sharing platform, right? And of course, we need to answer questions. Well, how can we make sure that data sovereignty is ensured and assured or even guaranteed to a certain level? How can we secure data exchange? And how can we really make sure that trust is not only, let's say, envisioned, but really materializes on these kind of platforms? Another example from the logistics or automotive industry, some of you might know the company called Here, which is basically, or was formerly a division from Nokia, mainly the map division. So they are the ones that create maps like Google Maps. What they want to do is, let's say, they want to be the Google for all physical assets. So if you want to know where your container just at this moment is, or when you want to know where your car is, or any other physical asset, you in the future should just go to Here, type in, let's say, what you want to search for, and Here gives you all the information. That is only possible if, let's say, all the different partners in the ecosystem make available their data, right? So the logistics service providers, the companies that send and issue certain transports, the ones that receive transports, and so on. And also, we need to combine that with context information like traffic, weather, all the other stuff. Another example is the corporate data league, which is a community approach for data management. So multiple companies, 15, 20 companies, large corporates come together to jointly manage business partner information, so master data on business partners like addresses, like Chamber of Commerce number, all these kind of things, or banking account information. And they simply use the power of many, right? Because if one partner in this ecosystem maintains and updates the information, it's by a press of the button on the save button in an ERP system, for example, that we have. It's immediately available for all the other members in the group, in this peer community. And so they are using, let's say, community approaches for joint management of data. Right. So I already mentioned that briefly. One of the key characteristics of these ecosystems is, next to the fact that we need to have our own data in good shape and need to combine it with, let's say, data from the business network and also context information like weather and so on, that we are able to share data. And let me also add a couple of thoughts about this terminology. Usually we use the terms data sharing and data exchange synonymously. I don't believe that it's precisely correct, because we have been exchanging data for decades. If you look, let's say, at EDI scenarios with multiple various standards for EDI data exchange, but it's really an exchange of data. So one company passes over the data to a third-party company, to a different company, and is usually not really interested what that other company does with the data, right? So the optimization, or let's say the scope of interest, so to say, basically is the own company. Sharing is something different. Sharing means that we use the data jointly, right, together. And that is something which also differentiates business ecosystems from value networks. In a value network, basically everybody looks at his own interest, whereas in an ecosystem, partners need to team up to jointly fulfill a common customer need. And therefore, also we need to use data together, as said. And we can see that here in a lot of scenarios, which are all taken from our initiative, like material science with materials data space. We want to share information along the entire product life cycle. We can see that, of course, in healthcare, where we want to share patient information, anonymized, of course, in order to come up with better medicine and better healthcare products. And we can also see that in the smart cities domain. And not coincidentally, all these kind of scenarios or domains taken out here are ones that are also driven forward in, let's say, at least forming, sometimes even existing vertical communities within our initiative. But if we want to do that, of course, it is clear that we don't want to give away this data and share this data for free. We want to have something in return, or at least we want to know what is happening with our data after we've shared it. And also to come back to the very early days of the IDS initiative, there was the former CIO of Volkswagen, which was Mr. Brunken. And he basically said, as we also learned in the beginning of this presentation, that making data available in good quality does not come at no cost, right? It comes at a cost. It is something that creates cost and generates effort for various people involved. And the interest of the German or even European or any industry in the end must be not to reside or be left alone with the cost of data creation and data management, but also be enabled to benefit from the value of the data. And if we want to do that and not only stick to the cost side of the data, but want to also play offense game, so benefiting from the value of data, we need to be able to control what's happening with our data even after we share it and make it available beyond our company boundaries. And that is the case for usage conditions and usage control in the end. And we can see that in multiple domains. To me, these cases are very, very clear, crystal clear, like in healthcare. I know as a patient that I'm better off if I share my data with Big Pharma. And I know that I'm even more better off, so to say, if everybody else does that. But of course, I have no interest of my health record being made available publicly in all networks. Same thing with production or predictive maintenance, for example. I, as an operator of a welding robot, know that my maintenance services that are provided either by KUKA themselves or by a maintenance service provider, that they will improve if I provide data from my production process. And I know that this will even improve more if also my competitor that runs the same robot system does that as well. But of course, I want to make sure that I can control who sees what in terms of my data and who does what with my data, so I'm still in the driver's seat. That is the fundamental idea for, let's say, the IDS and also usage control in general. And that, of course, tells us something about how we have to develop further the notion of data governance. If we take data governance as a pure defense game, by the way, we still have to do that. The proliferation of digital business models does not take away the burden of dealing with data governance in the defense game mode. But we need to enhance and further develop it to be able to play offense as well. So if we look at, let's say, this table, it tells us what we have to do in terms of data governance and transform data governance to the requirements of the digital age. So in terms of organizational scope, we need to broaden it from purely enterprise internal to ecosystem and involving also the customer. In terms of ownership, so the notion of the data owner as introduced earlier on by BOSCH does not really match the notion of data ownership in a business ecosystem, right? So in contrast to purely setting data standards, ownership is understood in our context now as executing property rights on data or even ownership rights. I know that this concept does not exist so far, therefore it shows a property right. So also stewardship, from just focusing on quality, stewardship will be more related to curation. So making sure that aggregate data records that basically come from different sources fulfill the quality needs of a joint use. In terms of organization, how do we organize data governance? In the past, it was mainly a hierarchical issue. And many of you, or some of you at least, might know the new institutional theory in management science, which basically differentiates between, let's say, controlling stuff by hierarchies. So a boss tells the subordinates what to do. And that is more or less what we've seen in data governance company internal-wise. But that wouldn't work, of course, in ecosystems, because our span of control doesn't go that far, right, from an internal company. So we need to think of, let's say, how different roles and responsibilities can be organized in a more market and community-wide approach. How can we create incentives for people to act accordingly and to act in a common interest? Data flows were mainly looked at from an internal application system integration point of view or business process integration point of view. But now we have data value chain. And a data value chain is something different than a data flow. It carries the notion of value in it, and also, let's say, the notion of value creation as long as we go downstream this value chain in a network. Also, when we look at, let's say, what governance rules in terms of usage, it was mainly access rights. So who is allowed to do what? So who is allowed to access a system to create data? And we need to extend this concept in the direction of usage rights. And that is something that, for example, Christian Jung and his colleagues from ISST are currently working on, and they have this nice picture where, let's say, access rights or access control moves towards usage control. And from an economic standpoint, not only focusing on the defense part of the game, like cost and value, cost and use value, but really market value. So, and how does that match to what we want to do with the IDS? I'd like to skip this view graph because we run a little bit out of time, and also, I guess, let's say, it is clear companies are still suffering a little bit from lack in trust and security, but also are in desperate need of an architecture and approach that ensures data sovereignty. And I brought a couple of examples how that materializes in the IDS. From, for example, supply chain risk management, where usage conditions, constraints are attached to the data once it's shared. Same thing in healthcare. We talked about that already. Talked about, let's say, the requirement to anonymize the data. For example, data record must consist of at least 150 individual records, which are all anonymized. And we can also see that in production environments, in particular 3D printing as a service provider and related maintenance services. These kind of rules are multiple. We need to identify them. We need to come up with a catalog of rules which allows data owners to configure their usage conditions to their data according to their own requirements. So we need to, as I said, come up with system support to do that in a user-friendly fashion. And also we need to standardize these rules so that they are unambiguously understood across company boundaries within ecosystems. This materializes as a, let's say, data ecosystem in which multiple actors, participants utilize the IDS software components, in particular the connector as outlined here, to attach usage constraints, usage conditions to their data as the data is made available to other partners in this ecosystem. Also, let me point out again that the IDS is not the 1001st IoT platform or IoT cloud. The IDS is rather an architecture to create interoperability and data sovereignty between the various different and emerging clouds and IoT actors that are out there. That brings me to, let's say, our ecosystem partners or roles, so to say. And we see, of course, here various roles that could take over certain activities in the overall list of activities that we need to undertake if we look at data governance from an offense game perspective, right? And that brings me also to my last slide, where I try to outline a little bit what governance activity needs to be carried out by whom and what software component should support these activities. If we, let's say, for example, look at the data owner or data provider role, his main activities, which are outlined also in the first, in the recent version of our reference architecture model, it's about, let's say, defining usage constraints for data resources, publishing metadata, including these constraints to the broker, but then also transfer data with usage constraints linked to the data, receive information about data transactions from the clearinghouse, for example, and also build data if required. And perhaps also a data owner wants to be able to monitor policy enforcement. So wants to monitor whether the usage constraints are met in a remote environment. And the key software component, of course, for that is the connector. On the other hand, we have the data consumer and the user, and he wants to use data in compliance with these constraints that are put to the data by the data owner. The broker is mainly for matching data demand and supply with the broker software, and again, not only free-floatingly, so to say, matching any demand and supply, but match that according to the usage constraints. So if the data is not available for everybody, but let's say the data owner has specified certain types of participants that are able to see that the data is available by the data owner, the broker, of course, has to take that into account. So it's about who sees what game, so to say, in the end, and he's allowed to do what if he is able to see the data. So clearinghouse, monitor and log data transactions and data value chain, potentially also monitor policy enforcement and perform data accounting. So making sure that data transactions are logged and also giving notifications when a bill could be sent, for example. And App Store providers, of course, offer data governance and data quality services through the App Store software. We are currently in the process of starting the editing process of the reference architecture model document version 3. And data governance has been one of the chapters which has, let's say, room for improvement or for, let's say, more content. And if we could fill that together based on this, let's say, basic and fundamental ideas, I'd be happy to be part of that. And that brings me to the end of my presentation. Thanks a lot for listening. Hope you find it interesting and hope you can take away a couple of things with it. I'm open for questions. Thank you.
Yeah, thank you, Boris. It was really an interesting lecture. Great ideas and starting points for data governance. As you mentioned, there is room for improvement in our reference architecture. We are addressing this, and I'm glad to have you here with us on this. So we already had the first question, a very important question. Are you willing to share your slides with everyone?
Sure, of course, yeah, that's what they are made for.
Yeah, okay. So for all of you who asked, we will share the slides, I think, via our website afterwards. So are there any other questions to Boris at the moment? So you can just ask or write something down in the chat.
Hello, I would like to ask you a question.
Yeah, go ahead.
Hello, my name is Toshiko Matsumoto from IBI. I would like to ask a question about how to define the purpose of data usage.
Yeah, it's a good point.
Because some of softwares are very general purpose, for example, business intelligence software or statistics analytics software.
Yeah.
So how we can classify the purpose of the software?
Yeah, that's a good point. So I believe, let's say, that we need to drill down a little bit into this concept of purpose in more detail by determining, so to say, what is being done with the data in terms of software functionality or service functionality. So you're right, that relates to the point that we need to also be able to describe software services in an unambiguous manner, but that would be the case, right? So we would need to be able to define and determine software service functionality in order to determine the purpose. You're right, but that also tells us, all of us, that there is still a lot of, let's say, work to do, because as I mentioned earlier on, both the conditions themselves, but also, let's say, potential values of certain usage conditions have to be defined and then also said unambiguously understood. So they need to be at least harmonized, so to say, right? Yeah.
Thank you very much.
Are there more questions from your side? So I would have a question, Boris. You discussed the value of data in your talk and about the need for protection and rules for the data. So is there any kind of generic method to define the value, the economic value of data available?
Yeah, there are. Usually you can distinguish 3 different ways to approach the valuation of data. It's basically as for any other good. You can, as I said earlier on, you can try to identify the cost of production or purchasing cost. So what does it cost to get possession of that data, either by creating it by myself or by buying it, for example. So that is a proxy for the value. So if I have the cost and I do not have any other thing or any other mechanism to determine the value, at least it's a good indicator what the data might be worth. The second is, and this is the most useful one, but also the most complicated one to determine, is the use value. So what does the data bring in my use case? For example, in the various use cases that we have in the IDS environment. And that is the most valuable and useful one, because it really tells me what contribution the data makes to my business success in the end. On the other end, it depends really on the nature of that use case. So, and therefore, there are mechanisms. For example, I can point to this, I think it's called benefits dependency network diagram, to really outline what I do want to achieve in a use case, to be better off in logistics, save logistics costs, for example, or reduce out of stock situations, which pieces of data I need and which quality, where do they origin from, and so on. And then really define, let's say, the use value of the data by comparing what if I have the data available in the sufficient quality compared to I have the data in bad quality or not at all. And this difference basically gives you the value contribution in that particular use case. As I said, very useful, but it depends on the use case. And the other thing, the American way to do things is just try to find a buyer for your stuff. So try if there is a market and see what the market will pay you. So that also gives you, of course, an indication. There are, let's say, a couple of approaches to also balance the value of data in terms of business acquisitions, for example. And I'm also in touch with the guys from Max Planck, for example, which in general deal with the value of intangibles. And that is a nice path in my way to pursue, because in the end, depending on the different nature of data compared to touchable, tangible goods, we will be able, in my personal opinion, to come up with accepted accounting and valuation approaches for data. And that's also why I find it very, very helpful that we have, let's say, companies like Bird & Bird and also Pricewaterhouse in the group, because it's their job then to take that to a practitioner's level, so to say, or a community of practice level, if you want to call it like that. Yeah.
So, are there any other questions from your side? I haven't received anything via the chat, but maybe someone wants to speak loud. If not, I would have some questions afterwards, but I'm happy to be here with Boris together, and so we can discuss on. Everyone who looks this on YouTube right now, you can comment below, and of course you can like this webinar with the button below. And of course you can always come back to the IDSA, and of course to Boris too if you have any additional questions or ideas. So I would love to say thank you at all, Boris, for your time and for this very, very interesting lecture, and thank you all for listening.
Yeah, pleasure was on my side. Thank you. Bye-bye.